So the next is angle of incidence हम discuss कर चुके हैं. The next is angle of prism. Children, I want to tell you one thing very clearly, and maybe you have done in maths also, that when the angle is very small, right, then wherever the trigonometrical ratios have been kept, that is sine, cos, we can ignore the trigonometrical terms and we can just take the numeric terms or the terms given in form of variables. So what I want to say is that as you see, we are discussing about angle of prism C. We have seen that n is equal to sine A plus dm upon 2 upon sine A by 2. ये था, ठीक है. So if we are taking a very small prism, okay, very narrow and a very small prism, in that case the prism angle will be very small, the deviation will be very small, and hence we will ignore the trigonometrical sign. तो उस केस में n is equal to a by 2, a upon ये हो गया, upon a by 2 हुआ, okay, or you can write it that a by 2 plus dm by 2 upon a by 2. इसको और आप खोलेंगे तो a by 2 by a by 2 plus dm by 2 upon a by 2, right? I hope the thing is clear. Let me use a black pen, that will be more visible. So this becomes 1, here n चल रहा है, ठीक है, 1 plus delta m upon a, 2 gets cancelled out. So this can be written as, यहाँ n आया, a plus dm, ये आपने LCM लिया, a आया, ऊपर a plus dm आया, a इधर चला गया, we get this value. So finally what you get here is that an minus a is equal to delta m, right? So delta is equal to a common हुआ n minus 1. So the deviation, whether you're calling it minimum deviation or any deviation, the deviation here is directly proportional to the prism angle. So the angle of prism, this formula also stands important for a narrow prism. Delta is equal to n minus 1a. Okay, so this derivation is also important. So you see that in the angle of prism, so for smaller angles, we have delta is equal to n minus a, which shows that the angle of deviation is directly proportional to the prism angle. Means as the angle of prism increases, the angle of deviation also increases. So this is the relation between the angle of prism and the deviation. Now we are talking about the refractive index. Refractive index depends, can also be taken as the material of the prism. Okay. So in this case also experimentally, the angle of deviation is directly proportional to the refractive index of the material. The more the angle, the refractive index, the more is the angle of deviation. And now a very important point is wavelength of light. This is a little, you can say, indirect relationship, right? So wavelength, you know that V is equal to n lambda. 9 से हम ये देख रहे हैं, and you know this formula, अभी से पहले भी देखा था. So which means the velocity is equal to the frequency into the wavelength. N is the frequency here. So when we are talking about light, so one thing you know that on wavelength, right, जिसका what I was saying is that you can say that when lambda increases, n decreases, and also the angle of deviation decreases. What we see is here that V and N are having an inverse relationship. When we are talking about refraction, we are talking about light, then this is C and lambda, right? So here it is showing you the refractive index. Refractive index आपने formula पहले भी पढ़ा था. N is equal to C upon V. ठीक है, C was the velocity. You just rub this out. A better explanation will be N is equal to C upon V here, right? So a better explanation here will be that it is depending upon the wavelength of the light. Wavelength of the light means if the refractive index is more, then the wavelength is less, okay? Or if the wavelength is less, the refractive index is more, and then the refractive index is more, delta is more. In other words, if the wavelength is less, the refractive index is more. When the refractive index is more, the angle of deviation is more. So you can say that wavelength is inversely proportional to the angle of deviation here. So these are the factors on which the angle of deviation depends.